This is Hacker Public Radio, episode 3689 for Thursday, the 22nd of September 2022. Today's show is entitled Linux Inlaws, Season 1, Episode 65. TerminusDB. It is hosted by Monochromic and is about 68 minutes long. It carries an explicit flag. The summary is TerminusDB NoSQL database.
This is Linux Inlaws, a podcast on topics around free and open source software, any associated contraband, communism, the revolution in general, and whatever else fancies your tickle. Please note that this and other episodes may contain strong language, offensive humor, and other certainly not politically correct language. You have been warned. Our parents insisted on this disclaimer. Happy, Mum? Thus, the content is not suitable for consumption in the workplace, especially when played back on a speaker in an open plan office or similar environments. Any minors under the age of 35, or any pets, including fluffy little killer bunnies, your trusted guide dog, unless on speed, and cute T-Rexes or other associated dinosaurs. Due to the use of a closed-source operating system from the northwest of the US of A, on the TerminusDB side, audio quality suffered a bit and may not meet the expectations of our listenership with regards to the usual audio quality of the podcast. We apologize for any inconvenience caused. On the flip side, we are happy to report that no animals were harmed or used for testing during the production of this episode, at least as far as we know. Welcome to Linux Inlaws, Season 1, episode I can't even remember. Unfortunately, Martin is not here tonight because he's feeling a little bit under the weather, but I'm more than happy to host this alone for a change. And I'm more than happy to introduce our guests for tonight. It's a project called TerminusDB, and with me are Gavin Mendelsohn and Luke Feeney. But without further ado, guys, why don't you introduce yourself?
I'm Gavin Mendel-Gleeson, and I'm a CTO for TerminusDB and one of the co-founders. So my background was in maths and physics, and then I went into computer science, got a doctorate in computer science, and then I was working on a project at Trinity College Dublin on long-range historical research, and we needed a database, and strangely, we decided to actually write one. So that's sort of the origin of TerminusDB and a bit about my background.
Luke, over to you.
Hi, thanks very much for having me. I'm Luke Feeney. I am also one of the co-founders of TerminusDB. I joined the gang after the technology and the company spun out of Trinity College in Dublin. My background is not in technology, but rather in diplomacy. So I work more on the relationship side of the organization, though I now provide some input into the tech side as much as I can, at least, to give some direction there.
Now, fun fact, Trinity College, full disclosure people, it's the place where I did a PhD about 25 years ago. Apparently, neither Luke nor Gavin were around at the time. But it's still the happening place that it used to be. I mean, I did the PhD in the very research group where Iona was a spin-off from, or by, or whatever you want to call it. And you're looking at kind of early 90s. And I reckon the rest is history. So maybe before we go into the depth of the project, maybe you can shed some light on actually how you met and how you founded TerminusDB, being a spin-off project of a research project, or being a spin-off of a research project at Trinity College. Because needless to say, TCD, or Trinity College, as it's also known, is still close to my heart because, as I said, I did a PhD there ages ago. So why don't you give it a whirl?
So when I was at Trinity College Dublin, I was invited there actually by Kevin Feeney, who's Luke Feeney's brother.
Ah,
And Kevin Feeney suggested that I work with him on a project that he was putting together, a European project, in which he was trying to involve long-scale historical research, some industry partners, and others that were interested in basically in big data management projects.
okay. And this
Then when
is,
we spun out, we needed somebody who was more on the commercial side, and so then as soon as we spun out, essentially we went and we approached Luke to see if he would be keen on doing it.
now look, that must have been quite a transition coming from the diplomatic side to software company, or startup for that matter.
Yeah, it's a huge transition. You feel like when you get off a ship after going on a long ferry, you feel like the ground is still moving around underneath you.
Okay.
It feels a little bit like that insofar as there's just so much information to take on board and so much secret language of technology that needs to be ingested before you can even sound credible. So yeah, it's definitely a big shift, but it's been very exciting, very interesting. It's great to do something very different so that you're, you're fresh, the world from an entirely different angle. You get to meet new challenges in a different way. One of the nice things about working in a diplomatic service is that there's always something new to do. You go off on an overseas posting to an embassy, and it's quite different from working in different bits of government. And that's definitely the same with startups. You have to kind of do a million different things at the same.
Okay. Now, when I hear diplomatic services, for some reason, and maybe I've just read too many spy novels, the intelligence angle rings a bell, but I reckon you were nowhere near that sort of focal point, being in the diplomatic services. Of course, you can't speak about it. Fair enough, but
yeah, but Ireland is somewhat unique insofar as we have no intelligence service.
This is the official version, of course.
We have the police, and we have the special branch of the police who do intelligence for policing. We don't have a specific agency that's offshoot of the military, or an independent agency like the CIA or MI6 or anything like that. In Ireland, there has been some suggestion through the years that we found such an agency. Nothing has ever come of that. So uniquely in Ireland, at least I can say that I can be 100% sure that I was not involved, unless I was recruited by a foreign intelligence agency, and that didn't happen, I can assure you that.
So MI6, if you're listening, these rumors of an Irish intelligence service are just that, rumors. No truth behind this. Moving just off to much safer grounds. Maybe you can tell us a little bit about the project itself, basically why you decided to spin this up into a commercial company, and then also talk a little bit about the history of Terminus after you spun it off from TCD.
Yeah, so I guess in the early period, we were evaluating different storage possibilities for a collaborative knowledge graph. So essentially, we knew we wanted something that was extremely rich in terms of schema that it could store. So our problems that we were looking at, for instance, were looking at human polities throughout human history, and we're trying to figure out, what you have to be able to say things about them that are both geographically and time scoped. So you might say, what is the population of Rome? And that population exists within some kind of range of error bounds, and then the period over which you think it's about that also exists over some kinds of ranges that also have error bounds temporally. And then you'll have lots of these sorts of data points. These data points are quite rich themselves. They're not just like a number. It's like a lot of information is bundled up into what they call a variable in SESHAT. So SESHAT was the global historical data bank that was trying to build these big, complex historical databases or knowledge graphs. And it extended far beyond just population. So it's also talking about the likely carrying capacity. It's talking about what kinds of rituals they practiced, whether or not they had human sacrifice, whether or not they had a doctrinal religion, the number of levels of hierarchy in the state, all kinds of things like this, various social complexity variables. So that meant very complex, rich databases that had to be managed over time, that would change, the ontologies would change, researchers would discuss the problems, and we had to somehow be able to allow curation by a large international group of people in some kind of coherent way. So it was a hard sort of data management problem that is actually pretty similar to a lot of things that exist in industry.
Okay, before we move on, maybe there are 2 or 3 people in the audience who do not know what an ontology is and how that sort of database that you are just describing as a semantically based graph database connects to the ontology aspect. Maybe you can shed a little bit on light on that for the slightly non-technical people in the audience.
Yeah, no, that's a very good. It's actually kind of a complicated philosophical problem. So ontology is trying to find out the categories.
Yeah. Sorry, we do have about 4 hours, so max yourself out.
Okay, yeah. So ontology is really just the logic of the meanings of things and how to categorize them and how they relate to each other. So semantic meaning and the sort of structure that you want to put on knowledge. So it's not really a schema per se, but you can imagine creating a data model from an ontology or having a data model that is supposed to in some way reflect the ontological structure of something.
So essentially what you're implying, of course, Terminus being a NoSQL database, as in a somewhat unstructured database, meaning if I understand this correctly, essentially you have an unstructured knowledge base that you're pouring into a NoSQL schema, for want of a better explanation.
Yeah, so that's not too far from the reality. So you have something that describes the sorts of things that we want, but we wanted much richer control over what was going into the database to make sure that, for instance, when people were putting in the population of Rome, they weren't putting in something random. So one of the problems we had initially, we were trying to source information from public sources, and one of those sources we used was DBpedia. And the DBpedia had, for instance, we wanted to import battles and wars into Seshat from the information in DBpedia. So DBpedia is a data bank that was developed from the info boxes in Wikipedia. So it's got a lot of information, a lot of very useful information. However, there's not that much in the way of quality controls on some of these things. One interesting problem that we ran into, we imported all of these wars, and we were searching through, and there was one about all of these birds. There was all these connections to birds, and we were like, why are there birds in our database all of a sudden? And it turned out that there was an ornithology war of 1865 or something like that, which is a completely not a war in any sense, but somehow had been imported into the war section of the ontology. So that kind of looseness is quite dangerous. And if you're trying to build a knowledge graph, you need to have, if you want to use it for analysis, for scientific analysis, you have to have a lot of quality control over what's going in. So a lot of what we were developing in the early stage was really data quality assurance technologies, trying to keep things so that they met a schema structure that was guided by an ontology.
Okay, this bird thing is really interesting. Did you by chance also tackle Coke Wars, as in between Mexico and Colombia, for that matter?
No, we didn't get those ones in. But that was
I'm just asking, that's all. Okay.
It was probably only because we didn't search those dates. I was importing for earlier, so.
So actually you said that you scraped Wikipedia, but also DBpedia.
DBpedia is a scrape.
Okay, got it.
It is a scrape from the info boxes in Wikipedia. And they take that data and then they also do some curation on that data to try to improve its quality.
And when I take a look at the Wikipedia page, funny that, of the C# project, it says that the global history database gathers data into a single large database that can be used to test scientific hypotheses. Now, that's a very interesting approach, isn't it? So essentially, you use historical data to confirm or reject scientific hypotheses beyond history, or as in generally speaking, or just historical hypotheses?
Well, I mean, it could. I mean, some of the implications are present today, right? But it is meant to test past hypotheses. It has also been used to predict future events. So, for instance, some of the information that was used, one of the hypotheses was used to try to predict the sort of Trump era instabilities 10 years prior. So essentially, there's a bunch of social variables that predict that there's going to be a likely crisis in the United States due to various different convergent elements.
But
that
you
was
haven't
supposed to happen around 2022. So
interesting, yet to come. What about the Klingon-Romulan War? Does that feature on your map?
Well, I mean, if we put it in, then we should be able to
Just
see
curious,
whether or
that's
not
all.
it's going to happen. Yeah.
Okay, very interesting background. So the idea was actually to monetize this in terms of spinning it out of this project. And I reckon that TCD was part of Seshat, as in the project itself.
So we were part of the Seshat project, but Trinity itself wasn't a partner.
Okay.
So it was like some people from Oxford, Peter Turchin, who was sort of leading the thing, but Harvey Whitehouse and Thomas Curie.
And going back to the spin-off, what exactly drove you to the conclusion that there might be a commercial market for this? As in, why did you take this concept from a research angle and put it into a startup?
So we were also in this. So the Seshat project was part of a larger European project on data management, and one of the other partners in there was Wolters Kluwer. And Wolters Kluwer is a big Dutch-German
mafia
data firm.
Sorry.
and they were interested in the technology, and so we had a project with them, and that's sort of what the genesis of the spin-out was.
Wow. And if I'm asked, why the name Terminus? Or TerminusDB for the matter?
So it's TerminusDB because so Terminus was the place in which there was a repository of all of the important human knowledge in the Foundation trilogy by Asimov. That's
the famous author. Okay, wow.
That's right. But we're also thinking about Terminus, the god, the Roman god, the god of boundaries. At the time, we were doing, a lot of data quality, trying to import information from places and put it into a knowledge graph that would have high quality data, and so you need boundaries, and so that's Terminus is the god of boundaries.
And if I may be so nosy, who came up with it with this name? The Feeney brothers or yourself?
I believe it was the Feeney brothers. Was it you, Luke? I can't remember where it came from.
It was you. It was you, Gavin. Stop trying to pass up the credit.
Okay.
We had an interim title between. So when we spun out of university, we were called Data Chemist. And Data Chemist still lives on. It's the consultancy wing of the organization. So when we do consultancy, we do chemistry on your data to make it all fit together nice and neatly. But we were transitioning across to being named after our principal product, and we were naming our principal product at the same time. So we were Regulum DB for a while. Regulum DB sounds like a laxative, though.
Dangerous.
We own the copyright to Regulum DB in case there are any budding database developers out there that want to buy it from us. We will sell it for a reasonable price.
Fair
We
enough.
were a little bit worried about Terminus because there were some French chaps who had a company called Terminus Media.
I see.
And we were worried that we wouldn't get a word right or copyright on the name for EU because it was somewhat similar. But actually they were very reasonable, and after a little bit of communication back and forth, they agreed that that nobody'd actually get confused by a movie company and a database company, and said that we could go ahead, formally said that we could go ahead and call it TerminusDB after both the Asimov and the and the Roman God. And Chris, as you know, the hard things, that the joke is obviously that the hard things in computer science are naming things, and that's definitely the case when it comes to naming databases. Cache coherence and off by one errors. So those are the two hard things in computers.
Okay. Changing tack a little bit, and given the fact that we have the CTO on this episode recording, I might as well ask some technical questions. If I take a look at a GitHub repo, there are two things that come to mind, Gavin. A Git-like engine, and apparently which is written in Rust as the underlying technology. Given the fact that this is almost, as in the Linux Inlaws, are almost half a Rust podcast, because quite a few episodes have been spent on tackling Rust from different angles, community marketing, and all the rest of it. And yes, we will have Rebecca Rumble on upcoming episodes that can be disclosed. So no worries. Maybe you can shed some light on the technology itself, why you went for this technology, and especially what sets the storage engine apart from other approaches. Redis comes to mind, Mongo comes to mind, and other kind of databases that claim to be pretty performant. For example, Redis does it basically all in memory. Maybe you can shed some light on your approach and the architecture, and also spill the beans on why you went down that route.
Yeah, absolutely. Maybe it's easiest if I start why we went down that route. So originally we were trying to figure out how to get extremely large graphs to function well for queries, and we did some experiments, and it looked like for Seshat we were going to be able to work with a sort of conventional graph database, and it was going to be fairly manageable because you were talking about tens of millions of edges and not that many. But we started doing some loading of, with a subsidiary of Wolters Kluwer, we did an analysis of the Polish economy, basically doing all of the, storing all of the companies, their boards of directors, all of the shareholdings, all of the, subsidiaries, and all of the people who are involved in bankruptcy proceedings, etc. So all of that information essentially since the fall of the Warsaw Pact. So going back to the early 1990s, and that ended up being over 1 billion edges, and that just wasn't manageable using any of the conventional techniques. So we searched around, and we actually found there was this open source project called HTT, which it's a RDF sort of static database. It's a load once,
sorry,
read many
Kevin,
times.
What's an RDF for these people who don't know, in the audience that do not know what that means?
That's right. Okay, so RDF was a semantic web standard that was developed, and it's basically just a format for storing triples. The basic idea is that you can have a named node, a named edge arriving at some target node, or a data point. So you have sort of two different types of triples, one that is node cross property cross node, and one is node cross property cross data. And that sort of framework is a very general framework for storing labeled graphs, and you can put a lot of things quite conveniently into a sort of RDF framework. It's in contradistinction, I guess, to property graphs, which have a slightly different approach to modeling. But I mean, they're sort of isomorphic in a sense. There's not a huge difference between them.
Mm.
In any case, HTT. So it came out of the semantic web originally, I suppose. The RDF structure. So we were trying to figure out how. So we decided to use this HTT as an experiment. We got a really big, massive machine with a lot of memory, and we just created a bunch of worker nodes to make lots of these little HTT files and then merge them all together into a gigantic plane that would then run in memory as a read-only database. And that worked quite well, actually. So we were able to go up to very huge databases with very good performance for recovering long chains, especially. So if you're looking up a single node, then you might be faster with some other type of database. But if you start looking down chains of nodes, this actually turns out to be a very good way of structuring the data. Now, the thing that's interesting about HTT is they were using something called a succinct data structure to store the information. And succinct data structures are queryable data structures that are approach the information theoretic minimum size for representation, while also being able to allow these queries in reasonable amounts of time, like logarithmic time or something along those lines, depending on what the precise operation is that you're...
Like a bitmap, essentially, for example.
Yeah, so bitmaps, exactly. So you have these sort of bit arrays, bitmaps. Those can be used. You can do logarithmic searches on things like that. And then there's other techniques. It's sort of a family of techniques for representing. And this was really cool. So these succinct data structures are very cool, but they're hard to write. So they like to be written once. They don't like to be updated, and they're a little bit tricky. There are dynamic structures and dynamic ways of dealing with this, persistency and things like that, but they tend to be write once. So naturally, we started developing the system where we would store deltas and then occasionally roll them up into a big flat plane when necessary. And if you do this in a clever way, you can sort of cleverly create a sort of log-like shape to the way that you have these planes as you update them. And that idea sort of naturally created a database which was A, immutable, and B, had a commit structure somewhat like Git. So it was sort of developed quite naturally out of this need to go up to very large graphs.
So that gives you version control pretty much out of the box, no?
Yeah, so that's
Come
the
to think
funny
of
thing. Yeah. So, I mean, there's some orchestration on the top. This is actually a fair bit of extra work. We thought it would be less extra work than it was. But so we could see, this is very much like Git. All we'd need is like branches, and then suddenly we'd have something a lot like Git just based on this structure.
And why Rust as the primary implementation language? Why not C or C++? Try it and test it.
Yeah, no, we started with C++. So we were using C++ to do using HTT's libraries and then modifying HTT's libraries to improve some of the problems that they had. And we really needed multi-threading in order to make it so that it was performant to do large assemblages, like when we're really creating a large graph. And that ended up in a lot of crashes. So there were a lot of like race conditions, and there was a lot of non-reentrant functions that were supposed to be reentrant, and they were incredibly difficult to track down. And so one of our engineers, Matthias van Aarde, he was sort of learning Rust in his spare time, and he thought, you know what, I'm just going to rewrite this library in Rust in my spare time, not at work, in my spare time. And then he came in and he was like, here, I have a working prototype. What do you think? And I was like, wow, that's pretty amazing. And we almost never suffer from those sorts of crashes or non-reentrant behavior.
Before we discuss Rust a little bit more, didn't you take a look at something called libboost or something to eliminate the complexity of multi-threaded C++ code, because normally Boost and that remaining ecosystem isn't supporting frameworks is existing and has kind of tackled the hard work already, or wasn't libboost and friends a fit for the project? Just curious.
Well, it would have meant sort of going through systematically everything in the HTT library and trying to tighten it up. So it turned out that a rewrite in Rust was probably on the similar scale of complexity to doing that. So I think it was probably, I feel like it was the wiser decision overall. It saved us a lot of time in adding various kinds of multi-threading and avoiding a lot of different kinds of bound checking errors. But Boost does improve things significantly over old style, fast and loose.
The beauty with Rust is, of course, in full disclosure, marketing portion starting right now for us isn't blatant marketing for us. Rust comes with a lot of components already in the standard library that you have to tack on your C++ code before you get it to work on the same level as Rust basically supports it with the standard library already. For example, multi-threading, channels and all the rest of it, where you have to resort to external libraries in C++. Rust basically has it as part of its standard library, which makes it easier, I reckon, to implement because it's part of the core library set or functionality rather of the language already.
Yeah, I mean the compiler's ability to help you is really not to be underappreciated as well. I mean, so you can take something like the GMP library, which is a multi-precision large number library essentially that's widely used. And if you look at the Rust libraries that use it, they basically just have a shim on top. They use a bunch of unsafe calls, etc. But they make it so that you can't shoot yourself in the foot very easily. And that kind of that shim above it is not the same as the way that Boost would be able to help you. So Boost can help you a little bit, but it really doesn't provide this ability to get the compiler to help you not shoot yourself in the foot in the same way.
So whenever I talk to people that have mastered the learning curve, they tend to tell me that Rust is probably not the easiest language to learn. What was the experience of you and your team when you decided to tackle that learning curve of learning Rust?
I wouldn't like it is kind of significant. The borrow checker is a weird way of thinking about things. It does take us longer to write code, I think. We spend less time. I think even C++ is, I don't know, there's some aspects of Rust that are so convenient that it may be almost neck and neck with C++, but it's kind of similar. It's not like a high-level language like Python where you can just, out really quickly. You do spend some time, even once you understand what's going on, fighting the compiler, trying to get the type checker to pass. But it's worth it, And the original, eventually, there is a point at which you're like, okay, and the basic ideas of the borrow checker kind of sink in. I would say it took me sort of a month before it kind of made sense enough that I wasn't constantly fighting, an uphill battle. But I think other people pick it up quicker.
Full disclaimer, Gavin just talked about advanced, I wouldn't say advanced, but rather basic to the media concepts in Rust. There is a previous episode of something called Linux Inlaws where we tackle these problems, or these concept details will be in the show notes. And of course, there's also the language project homepage where these concepts are explained in depth. So we won't tackle them now. But so if I understand this correctly, Gavin, the old Rust adage still applies. If you can convince the compiler to generate code, you're almost there. As in the amount of time that you have to spend on debugging your code is really cut down, because much of the effort that is normally spent after you get a build on debugging that build is actually done prior to generating the executable, because the compiler basically takes the code apart and puts it back together again.
Yeah, I mean, obviously, you can use types in more or less sophisticated ways, But the kinds of bugs that it kills with the type checker that I think are really the most important ones are those sorts of like race conditions, seg faults, things that end up really being difficult to track down. So your bugs tend to be more like logical errors and more like the kinds of things that you'd mess up in something like Python, where you have a simpler language, you just messed up the idea, and you don't have this mysterious sudden crashing that is like, if crashes happen in a very irregular or unrepeatable way, it's really hard to get rid of them. So much nicer to never have those sorts of sudden sudden bugs that you have no idea where they came from and can't repeat them on a second go.
Oh, interesting. Changing tack just a little bit. The Wikipedia page about TerminusDB tells me that you changed licensing halfway in between from a GNU license to Apache, which is a very interesting move. Maybe you or Luke can shed more light on the background and especially why you did this. Because normally projects tend to do it the other way, moving away from a more permissive license to a more communist/restrict license like the GNUs of the world. Or GPLs for that matter.
We would have done that if we'd been overwhelmed with popularity on our initial release. Then we might have been becoming more restrictive rather than more permissive. But we had a bunch of users coming into the community and chatting to us who, wanted to build a application with the software, but felt, even if it was unjustified, had a general feeling that they were going to be caught up by the licensing and that they had liberty to build with the licensing. So we decided to go open source. We'd open source the software with a GPL 3, we didn't feel that there was any real issue for those people in just building with the software, that there wasn't going to be any copyleft provisions that were going to get in their way, but they had the feeling that there was. They had the feeling that their organizations weren't going to be in a position or a willing position to use GNU-style licenses. As you probably know, like Google, it restricts the use of certain GPL licenses entirely. So none of the AGPL licenses are allowed in any Google software at all, and not allowed to be used within the Google organization. Also, unfortunately, for better or for worse, there's a chilling effect that takes place then. And when we wanted the software to spread as broadly as possible, we thought that the Apache was the better balance there. So it was with a little bit of regret and a slightly heavy heart that we made that decision, but I think it's the right one for databases, because it does allow people to build as permissively as they need to.
AGPL, of course, referring to the FRO GPL, which is probably one of the more stricter GNU public license versions out there. Essentially, basically, it's viral communism at heart. Essentially, if you talk to an AGPL license component, even through an API, you have to essentially disclose as and reveal as and publish the source code. Details maybe in the show notes, but of course there's also a previous episode of something called Linux Inlaws where we actually discuss open source licenses. But back to the issue at hand. So essentially, if I understand this correctly, you changed that licensing model to increase adoption, which is a rather interesting move, if I may say so.
Yeah, that's exactly it. We increased it in order to increase adoption and increase the ability for people to use it to build within companies, within enterprises. Without the fear that they might be in some way restricted by some legal provision within the license at some later stage.
And this is the feedback that you're getting from the community too, after this change?
Before and after the change, yeah.
Interesting, okay.
Yeah, so definitely we got that feedback a bunch of times within the financial services sector. And, I mean, problem is one of the things that we'd observed when we were out talking to companies, talking to people about their problems, is that people were using GPL licenses in ways, or GPL software in ways they probably shouldn't anyway. They were embedding it. They weren't telling the companies. They were doing all sorts of shady stuff. And we kind of felt, well, if people are doing that sort of stuff anyway, we should probably just say that the Apache 2.0 is good enough, and it's definitely been somewhere where we've been comfortable to land.
Interesting. So it's interesting to see. It's interesting to see what happens if you change that license. Changing tack once again. If I take a look at your website called TerminusDB.com, of course, links will be in the show notes. I see quite a few offerings apparently built on top of TerminusDB. I see the core technology, TerminusDB, but I also see Terminus X, Schema as a Service, Version XL, and some other stuff. Maybe. And this is, and without basically going too much into marketing, maybe you can shed some light on the efforts that you try to monetize on top of your open source core technology.
Yeah, so only too happy to discuss that. Yeah, we have Terminus X, which is a database as a service. We're actually going to transition that across into a slightly different model. Into being more like what we're calling a beta builder. So a service where people can come along and they can test out building a beta using our cloud platform. It gets anybody over the hump of having to get their own software running, doing their own deployments, building their own CI pipelines. So they can come, they can use our API, they can get started with their project. They can then see if it's successful, see if the software works for them, see the graph capabilities, use the query language, build knowledge graphs and have them running as production applications. But then the idea is that people will transition across to their own deployments, because as things become more successful, people will want to govern better performance and parameters around performance. And we'll help with the deployment to any cloud that they may have, and rolling out of any enterprise features. So Terminus X will become more like a beta builder, a cloud environment for people to go get started. Not like it's like a sandbox on steroids. So it's like people often offer sandboxes, but this is one where you can actually build a production application very easily in the cloud, and then transition across to having that in your environment with our support and our enterprise package. Really, that's where we see ourselves making more commercial deals in the future, is on that transition from something that you're rolling out as a beta into something that you want to deploy in one of the hyperscalers in Azure or in AWS or and we're obviously ready to do that at short notice. And then we offer support around that, all those sorts of things as well. We have some supplementary products that we've built on the back of the software, and for various different reasons. One of those is Version XL, which you mentioned, which is an Excel versioning tool, which effectively treats Excel like a front end, or like an interface for the database. And then another one is a critical asset management for understanding climate resilience, and we built that with the United Nations so that developing world communities can better understand cascading failures of critical assets in climate-stressed environments. And given that we're a graph database, you can do those sorts of queries very simply to how assets might be linked together across multiple.
And now he's gone.
Yeah.
Okay, maybe you could chip in, because this is not working with the audio.
Yeah. So just on that, people building applications on Terminus X. So one of the features that we have is we have a very Git-like structure, and it's a distributed database in the same sense that Git is a distributed database. So you can sort of manually move around changes from place to place. So if you've built something on Terminus X, it's actually quite simple to just clone it and pull it into some other TerminusDB installation. and you can just do it over the wire. So, and it can do incremental updates, and incremental backups can also be done this way.
Interesting. So taking a look at the offerings on your webpage, TerminusDB as such as an open source code base can be found on GitHub. Terminus X is your managed service offering. Of course, you're probably charging money for this. But what about Schema as a Service version XL? These would be open core products as in relying on TerminusDB, but essentially turning the company into an open core company as an open core approach, where where the core technology, similar to Redis, Mongo, Couchbase, and whatever, is on GitHub, but the other stuff, especially the managed services, are paid for commercial products.
Yeah.
That's right.
Yeah, and I mean, I think the big focus for the Schema as a Service is to offer additional functionality to MongoDB users. MongoDB users that want to do path queries, that want to have any of those Git-like version control features, to make that very, very simple for them to do, and to make then obviously the ability to define a strong schema for your MongoDB data. One of the nice things about Terminus in general is that it's both a graph database and a document database. So what we call a document graph. I can interact then very nicely with MongoDB and its JSON document structures in order to do that. So really, some of those deficiencies that exist within the Mongo ecosystem, we're trying to pick up on, and help users that are there to do some of that stuff. And I mean, I think the version XL is exactly the same insofar as it's a layer that's built on top of the open source database, or open core model.
Interesting perspective. And now for the really bitchy questions in terms of we're an explicit podcast. Now changing tack a little bit, moving on to community marketing. If I take a look at a website called db-engines.com, I see Neo4j at position number 18, 19 maybe, Tiger at 122, Redis at 7, I think, and Arango at 75. Now, these would be all multi-model databases or native graph databases, which you may or may not consider as a competition. But if I check out Terminus, it scores at position 309.
Yeah, that's a fair point. I think that ArangoDB we definitely see as competition. I mean, they also do that crossover between document and graph. So they're a great database, and they also changed their name. They used to be. So I think that databases that have changed their name that are about document and graph are competition, but. We'd be very negative about DB engines and the way that their algorithm works for the ranking. A lot of it is about how many times the database has been mentioned in job advertisements, and other things like that. So Oracle remains on top always, and MySQL comes second. So I don't think it really reflects that well on younger databases and their ability to impact on the market.
Okay, apart from DDoSing, what do you intend to do about this DB engine ranking or not? Given the fact that, as you said, DB engines takes multiple vectors, which at times may not be that accurate. But as a matter of fact, to some extent, they reflect the community echo of your code base, of your adoption, of the adoption in the community. And any thoughts on this one? What do you do with regards to community marketing? And of course, links within the show notes as applicable.
Yeah. So the things that it takes into account are, we're not really sure exactly how they're balanced across their algorithm, but obviously we do try and become more relevant in social networks and professional networks, and we spend a lot of time and effort on trying to build a community that is inclusive and helps users to better understand the technology. We run a a Discord server where we try and respond to users' queries as quickly as possible. And we have a Twitch channel where we do a bunch of live coding for anybody that's interested in coming along and seeing some Rust or Prolog coding. We do that. So yeah, I think you'll know, Chris, it's a slow process building a community, especially if you're trying to build it in such a way as it's durable. It's a community of people that are genuinely interested in the technology and genuinely interested in building. And we have a kind of, an active user base within our community who are building really remarkable things in different areas. So yeah, I think we will climb up the DB Engine's ranking because we'll get better there, but we'll just take quite a while for us to catch up with some of those more established databases. Even if, of course, our performance, our technology, our people, and everything about us is better than all of the other databases that you mentioned.
Absolutely. You see, otherwise, Luke, I wouldn't be talking to you in the first place. No, I'm joking. No, jokes aside, people. Where do you, moving on to way safer grounds now, where do you see this going? Not just in terms of the open source code base, but also in terms of maybe the commercial offering or maybe the community in general. What's next for TerminusDB?
Well, we're great believers in the ideas around data mesh that have been so thoughtfully expanded by people in ThoughtWorks and elsewhere over the last couple of years. And Zhamak, who's kind of the founder of the modern socio-technic data mesh distributed architecture. So what we'd like to do and where we'd like to see it grow over the next few years is to build out a series of features that allow us to be a drop-in distributed data mesh for data-oriented organizations that want to push data management out to domains so that this incredible monolith of the modern data stack at the center of a lot of organizations can be broken up to give more flexibility, give more durability, and give better results for users, so that people sitting in marketing or sales aren't subject to the whims of data engineers at the core, but can actually build and create data products that can be surfaced to the rest of the organization, by themselves and can be modeled there. So we're very much on that left-hand turn of moving back towards a more heavily modeled world of data. What we'll do kind of probably in the near term is launch what we'll call a knowledge management system. So like a CMS, but for knowledge rather than just content. So that's kind of where a lot of our technical effort is going in now, is to build out the features around that. But we'll slowly over the next kind of year put together all of the features so that we can be a drop-in data mesh type environment for the enterprise.
Now,
I'm sure. I'm sure.
Yeah.
Now I didn't discuss this with Gavin in advance, so
Nice one, people. Nice. Now, jokes aside, that dangerously moves you close to something called machine learning, deep learning. If I take a look at ArangoDB and the strides they're making, especially in the machine learning curve, with regards to, for example, something called ArangoPipe, where they explicitly position themselves as the graph database of choice for machine and deep learning, with the architecture on top of the existing ArangoDB core. And as I said, knowledge, I see this moving towards machine learning very quickly. Where do you see this going? I mean, do you actually want to enter that space, or want you keep it on a kind of fairly high semantic level without going down that artificial intelligence route?
Oh no, we definitely want to go down that artificial intelligence route, definitely, because we think we're a lot better choice than even ArangoDB, who are very, very good. We think the revision control features of TerminusDB make a lot of sense. We think our approach to data modeling is the better one. And we also fundamentally think that our query language is better. We think that that the world will move towards data log. If you look at I don't know if you've ever come across them, Chris. Now, there's a company called Relational AI. The former CEO of Snowflake, Bob Muglia,
Rings a bell, yes.
He joined their board recently. And they are like, hey, we're going to take graph databases and we're going to make them work with SQL. And then when you look under the hood, it's like, yeah, okay, you can do a few things with SQL, but if you want to do anything exciting or interesting or next generation with this new way of looking at data, you have to go into using their variant of data log. And so we think that databases and data stores that have those sorts of abilities built close to the core are going to be the ones that win out in the end. And Terminus has already been deployed in a whole bunch of machine learning, AI, infrastructure projects. We're members of the AI Infrastructure Alliance, which is building a new canonical stack for AI. So we really do see ourselves, and we see version control data as being fundamental to tomorrow's machine learning and AI.
Interesting. Okay. Any thoughts on on something called quantum artificial intelligence? I mean, this is the stride that D-Wave and friends are making into a much more commercial adoption of their technology. So when can we expect the next version of Terminus actually talking to the likes of D-Wave, IBM, and some other quantum companies out there? Anytime soon?
Good question. Yeah, no, we'll have a version in a couple of weeks, just to.
People, you heard it here first. No, jokes aside. I mean, it's a niche, but it's a very it's a very quickly growing niche.
I'm running this software for this podcast on my quantum computer right now.
Excellent. So what could possibly go wrong, Luke, in that case? Okay. No, jokes aside.
In parallel.
Yeah. Anything that we should touch upon before we close this off as and move on to the proxies?
But he really gave a good overview of where we're going and the way we see the world, I think, at the moment.
Gavin, do you have something to add maybe on the machine learning side and kind of, why you think Terminus is
Yeah, so why is Terminus?
I mean, now's the time, exactly, yes.
Yeah, exactly. So I guess, we talked a little bit about succinct data structures and a little bit about the data mesh. So essentially, in order to leverage this sort of knowledge repositories that we have, you want to build knowledge graphs, but you can't build a knowledge graph of everything all at once, because then it becomes totally unmanageable and you don't know the ontology that you need to use for all of these different segments. So you need sort of domain control, and really what you want to do is create a network of knowledge graphs that creates an Uber knowledge graph out of combining individual knowledge graphs. In order to do that, you need some kind of mesh approach. So you need to be able to create these individual data products, and you need to mix and match them. And you need some sort of way to perform queries over a union of these in some sort of in a fairly effective manner. And Terminus's use of succinct data structures is really it really forms a good sort of backbone for doing this. And we were looking at some people in industry that were, spinning up hundreds of SQL light databases, merging them together into a giant sort of Uber database and doing the queries over that. And it turned out that was much faster than, say, like Amazon's Redshift. So this is actually a very effective way to approach the problem if you can do these sorts of, piecemeal merges of the problem domains that you need to create the network that's of interest for an analysis across maybe many different kinds of data products. And I do think that, the combination of data mesh and the combination of sort of succinct data structure scaling is really where we see ourselves trying to hit in a year. We're not really there yet, but we intend to be there in about a year.
Okay. Luke, anything to add?
No, I think that captures it pretty well. That there's a combination of factors that really work well with TerminusDB on data mesh and machine learning, and really about trying to now it's trying to both finish off some of the features that will enable that, like querying across data products effectively, picking and choosing from data products effectively. If you're a downstream user, like a data scientist that wants to run some experiment, and then just interfacing with existing enterprise architecture. As we all know, once you try to do deployments into enterprise, you run into all sorts of historic beasts and have to engage in a whole bunch of data archaeology. And there's a lot of potential for integration work, and we're trying to short circuit as many of those problems as possible, so that when people do make the decision to implement a data mesh, which of course is not just a technological decision, it's often more an organization or a social decision than anything else, because you're required, or you need to do redeployment of teams out to the domains to make sure that the expertise is where it needs to be, rather than building these very dense cores within organizations. So once you're making those decisions, that the tooling is available to make that easier. And again, that means that you've got to think about how enterprises actually use software, and how we could make that a little bit easier.
That has been more than an interesting hour of technical and non-technical discussion. One of the things that we do to close the show off is actually to discuss POXes. POXes stands for the pick of the week. Essentially something that has crossed your path over the last 1 or 2 weeks, which you think is worth mentioning. It can be a book, it can be a piece of software, it can be a movie, it can be even maybe a TV series, as in whatever is shown on Netflix these days, or it can be, of course, if you choose to do so, a piece of Irish politics. So, what's your pick of the week, Gavin? Your POX?
Well, I think it's going to have to be Carbon. So Google's Carbon, they just launched, I don't know if it was last week or the week before, but it's very new. The 20th of July or something like that. And it's their answer to C++. And it's interesting. It looks like it's angling to be a Rust killer. So that's
really? Oh, wow. Okay.
That's how I kind of see it. So, even the syntax has some kind of feel to it. So it looks to me like Google feels that this thing is going to happen, C++ is going to die, and they'd rather replace it with their own than get stuck with Rust. But that's sort of my naive read of it. Maybe other people looking into it have a better read.
Of course, links maybe in the show notes. What have happened to Golang in that case?
Yeah, screw Golang, right?
Fair enough. Google invention too, I might add. Okay, check this out, people. As I said, links will in the show notes. It's on GitHub, as in they have released this.
Yeah.
Okay, perfect. Luke, what's your POX?
Oh, it was a great choice by Gavin. I thought he was going to say something about carbon, as in people fighting about carbon budgets, because that's all that's going on in Irish politics at the moment.
Fair enough.
Obviously, it's something else. No, what I'm going to mention is I was on holidays last week in the south of France, and I read a book that I really enjoyed by a Peruvian author. Or no, he's not Peruvian, he's Chilean, which is called When We Cease to Understand the World, which is a non-fiction novel, if such a thing makes sense, which is about mathematics and physics, and about the people losing themselves when they get close to the core of mathematical ideas. And it threads a beautiful thread of modern physicists and mathematicians from the 19th century through till quantum mechanics, and about their psychological states and how they approach the world. And it's a short read, and very, very, very enjoyable for anybody that's interested in physics and interested in human psychology and the crossover of those things. I'd recommend it. The other thing that I'm a regular reader of, which I can only recommend to your audience, is Ben Stansel's Substack. So that's Ben, BENN .substack. He's a great writer about data in general, and had a couple of great recent blog posts. One called the Data Config about a humble YAML file with ambitions for more, and another one about data-driven companies, whether they actually win or not, which kicked off a bunch of conversations within Terminus.
Okay, isn't humble YAML a contradiction in itself? I'm just asking. Sorry. Okay, and a plain English version, as in translation of the book you mentioned first, is available too.
Yeah. It's all in English. Absolutely.
Excellent.
When we cease to understand the world, it's available on,
Fair enough.
on Amazon. I read it in English, of course.
That sounds
good enough.
Fair enough. That sounds very interesting. My POCs, and just to keep this short, because we're almost approaching the 2-hour mark. Though I'm joking, we're just running over an hour. Mine is a movie called Chirac. It's from 2015, done by a director called Spike Lee, if I'm not completely mistaken. And it's a modern-day adaptation of the ancient Greek play called Lysistrata. Essentially, it's about two conflicting parties, let's put it this way, where the women simply get fed up with the violence, also in ancient Greek, as in Greece, sorry, and they tell their man, sorry, if you have two choices. Either you stop this war or this conflict, or you basically will have to live without physical encounters, as in sex. Now, this one is actually set in modern-day Chicago, and it's very funny to watch, because what actually Spike Lee did, he took portions of the ancient Greek play and put it into the mouths of the likes of Wesley Snipes and Samuel L. Jackson. So if you're game for that sort of thing, that's a movie not to be missed. It's probably available on Netflix and other streaming services. As I said, it's from 2015. Links, of course, within the show notes. Luke. Gavin and Luke, no particular order. Thank you very much. That has been more than interesting, and hoping to have you on the podcast in a couple of years' time when you have moved to position number 1 on something called DB Engines, if it still exists and is relevant. Thank you. This is the Linux Inlaws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
This podcast is licensed under the latest version of the Creative Commons license, type Attribution Share Alike. Credits for the intro music go to Blue Sea Roosters for their song Solid Market, to Twin Flames for their piece called The Flow, used for the segment intros, and finally to Celestial Ground for their song Sweet Justice, used by the Dark Side. You find these and other ditties licensed under CC at Jamendo, a website dedicated to liberate the music industry from choking copyright legislation and other crap concepts.
Been listening to Hacker Public Radio at hackerpublicradio.org. Today's show was contributed by a HPR listener like yourself. If you ever thought of recording a podcast, then click on our contribute link to find out how easy it really is. Hosting for HPR has been kindly provided by anhonesthost.com, the Internet Archive, and rsync.net. Unless otherwise stated, today's show is released under a Creative Commons Attribution 4.0 International License.